Hello and welcome to my channel. Today I'm going to go through a sneak preview of sodium metal, that is the extraction of sodium metal. So the most important things you need to know is one, the chief ore, and it is called rock salt, which is sodium chloride. The other thing you need to know is the method of extraction, and sodium is extracted by a method called electrolysis. The reason for that is because it is a reactive element. During electrolysis, an impurity is added to the sodium chloride, and the impurity is calcium chloride. The purpose for that is to lower the melting point from about 800 degrees Celsius to 600 degrees Celsius, and that is to lower the cost of production. So let's look at the down cell, and that is the electrolysis process of sodium metal. As you can see in the diagram here, we have the cell. Inside the cell we have sodium chloride and that is our chief ore. It is molten, and the solid sodium chloride is heated, just as I've told you, from 800 degrees to 600 by lowering the melting point by adding calcium chloride. So in the mixture we have sodium chloride and calcium chloride. You can see there that is a mixture of molten sodium chloride and calcium chloride. So that is what is placed inside the cell. Now let's look at our cathode. We have our cathode here. It's made up of steel. We have two, one on the left and we have another one on the right. Then in the middle we have our anode. Our anode is this one. It's made up of graphite, or can just say carbon anode. So what happens is that during the electrolysis process, our sodium ions will be attracted to the cathode, as you can see there. And during the electrolysis process, what happens is that the equation at the cathode is sodium ions will gain electrons to form sodium metal. This sodium metal, you can see, is being collected in form of molten sodium. And then at the anode we have chlorine. The chloride ions will move at the anode, and here they lose electrons to give us chlorine gas. The equation at the anode is clearly here. We have chloride ions losing electrons to form chlorine gas. Now this chlorine gas escapes out, as you can see, and it is collected for other purposes. Further than that, we are now going to look at the major kcse questions which are examined on sodium. Welcome. So we start with 1997. The question was in paper 2, and the question was: the diagram below shows the extraction of sodium metal using the Downs cell. Study it and answer the questions that follow. You can see our down cell. So you can see sodium chloride, which is being put inside sodium chloride, and then we have molten sodium chloride and calcium chloride. That is our electrolyte and the impurity. And then we have our cathode, which is made up of carbon, and then, sorry, not carbon but steel. We have one on the left and the other one on the right. And then we have a steel gauze diaphragm. I think I forgot to mention it when you are looking at the recap. The steel diaphragm is meant to separate the anode and the cathode, and this will prevent the combination of the sodium and the chlorine. Otherwise you'll just go back to the initial sodium chloride, and that is a waste. So we really need that steel diaphragm. And then we have our anode, you can see here. And then there's a gas that is exiting through the upper part. And then also we have molten sodium. So let's look at the questions very fast. The first question is: explain why in this process the sodium chloride is mixed with calcium chloride. Explain why in this process the sodium chloride is mixed with calcium chloride, for 2 marks. So what did we say? to lower the melting point. So the answer is to lower melting point. Of the electrolyte. To lower the melting point of the electrolyte from 800 degrees Celsius to 600 degrees Celsius, so as to lower the cost of production. Then Roman 2, why is the anode made of graphite and not steel? Why is the anode made of graphite and not steel? So you can remember that in our diagram we saw it is carbon, and carbon is the same as graphite. Graphite is a form of carbon. So our anode is made up of graphite to prevent it from reacting with chlorine. So our answer is to prevent it from reacting with chlorine gas that is formed. So remember, at the anode, the product that is formed is chlorine gas. So if our anode was made of steel, which is iron, then it means that the chlorine would have reacted. So to prevent that, we use carbon, which is inert. Then next we go to Roman 3. State 2 properties of sodium metal that makes it possible for it to be collected as shown in the diagram. State 2 properties of sodium metal that makes it possible for it to be collected as shown in the diagram. Clearly you can see our sodium metal which is being collected up there. So one of the reasons is that it has a low density, that's why it is floating on the surface there. It has a low density. And then number 2, it has a low melting point. Has a low melting point. You can see it is being collected as a liquid. That means that the temperature inside the cell is higher than its melting point, therefore it remains in the liquid state. Roman 4, what is the function of the steel gauge cylinder? You can see the steel gauge cylinder there. The purpose is to prevent the recombination, to recombine is to mix, so to prevent the recombination of sodium and chlorine. To prevent the recombination of sodium and chlorine. Let's move further. Our next question is, write the ionic equations for the reactions which will take place at cathode to anode. So each we have 1 mark, so I'll start with cathode. So remember we said at cathode the product that is formed there is sodium metal. So what happens is that the sodium ions migrates at cathode, and remember it is in liquid state, that is the aqueous sodium chloride, therefore the state symbol will be liquid. So the sodium ions will gain 2 electrons which are originating from the anode. I'll explain that why I'm writing 2 and not just an electron. And this electron, when gained by the sodium ions, we get sodium metal, which is in liquid state because its melting point is low, so the state symbol is liquid. So to balance that, since we have 2 electrons, it means that we have 2 ions, so I write 2 before sodium ions. 2 ions, sodium results to production of 2 sodium metal. In the second point question, we have question at anode. So at anode we are having chloride ions, and these chloride ions, which are also in liquid state, will lose electrons, and on losing electrons they are going to give us chlorine gas plus electrons. So the reason why we are losing 2 electrons is because chlorine formed is a diatomic element. That means we have 2 chloride ions here, and that means that we have 2 charges, and therefore it results to the loss of 2 electrons, which are the ones which will be gained at the cathode. Roman 6, give one industrial use of sodium metal. Sodium has so many uses, but you just choose your best. So like here, you can give one use of sodium. You can say used in street lamps. Used in street lamps. The last part, explain why the sodium metal is stored under kerosene. Reason why sodium metal is stored under kerosene is because it is highly reactive. It is highly reactive with air. It is highly reactive with air. You can even add and water. Moving on, let's see, we also have another year, that is 2005, when this question was also examined. So very fast, I'll go through the question in 2005. The question goes, below is a simplified diagram of downcell used for the manufacture of sodium. Study it and answer the question that follow. So you can see we have our downcell, and in our downcell labeled we have a hole through which sodium chloride is being added. That is our chief ore, the electrolyte. And then we have chlorine gas leaving, and then down there we have a circular steel cathode, which is being separated by the diaphragm, steel diaphragm, if you can remember. Inside we have our anode, which is circular, which is made of we said what? It's made up of graphite because it's inert. And then on this other side we have another set of cathode made of steel, and then we have molten sodium chloride, our electrolyte. So our sodium is being collected on our extreme right on top, and I've told you the reason for that. It's because it has a low density. So what is our first question? Roman 1, what material is the anode made of? Give a reason. So clearly our answer is going to be graphite. Why graphite? Because it is inert and therefore it will not react with chlorine. Next question, Roman number 2. What precaution is taken to prevent chlorine and sodium from recombining? You can see this question has just been paraphrased from our former question. The other time they had asked us the purpose of the steel gauze. This time they're asking us what precaution is taken to prevent chlorine and sodium from recombining. So by use of a steel gauze, diaphragm. So this prevents the combination of sodium and chlorine. Roman 3, write an ionic equation for the reaction in which chlorine gas is formed for 1 mark. So here we are writing the equation at anode, and at anode you're having chloride ions which are losing electrons. Don't forget to put state symbols, and when they lose electrons they give us chlorine gas as our product. So make sure your ionic equation is balanced. Next, in the Downs process used to manufacture sodium, a certain salt is added to lower the melting point of sodium chloride from 800 to about 600 degrees Celsius. Roman 1, name the salt that is added. I think you can recall that we said the salt is called calcium chloride, and you don't write the formula. They've asked you to do what? To name the salt. So our answer will be calcium chloride. Next, state why it is necessary to lower the temperature. We are doing that to lower the cost of production. To lower the cost of production. So in the exams, you have enough space. You have to make sure that your question answer is well paraphrased. I'm trying to squeeze here, that's why you can see that, but don't summarize as much as I'm doing. Then we go to part C. Explain why aqueous sodium chloride is not suitable as an electrolyte for the manufacture of sodium in the Downs process. I'll come again. Explain why aqueous sodium chloride is not suitable. You can see not is in bold. Otherwise, you may rush thinking that it is suitable. So the reason why we do not use sodium chloride that is aqueous for the electrolysis, instead we use molten sodium chloride, is because if we use aqueous sodium chloride, hydrogen ions instead of sodium ions are going to be preferentially discharged, and that means our major product at the cathode is going to be hydrogen gas. Yet you are manufacturing what? You are manufacturing sodium metal. So explain why. Our answer is going to be because hydrogen gas will be produced. So we have looked at electrochemistry, and in electrochemistry, hydrogen is above sodium in the electrochemical series. And therefore, between the two, the one that is discharged when you have the ions in solution will be hydrogen. Therefore, we will not be able to get sodium metal. We go to part D. Sodium metal reacts with air to form two oxides. Give the formulae of two oxides. So this one is an easy question. They just want you to give the formulae. Our first oxide is called sodium peroxide, which is N2O2, and it is formed when you have sodium reacting with excess oxygen. Our second oxide of sodium is sodium oxide, limited oxygen. Lastly, give any two uses of sodium. So just as we saw in the previous question, sodium has various roles. We can give the one that we had mentioned, one used in street lamps because it gives the yellow glow. Yeah, street lamps. You can also add another use of sodium. You can say sodium is used to manufacture sodium cyanide. Sodium is used to manufacture sodium cyanide that is used to extract gold. It is used to manufacture sodium cyanide that is used to extract gold. So I'll advise you to at least get to know 5 uses of sodium, because you can see clearly that uses of sodiums are always there. So thank you very much for watching the video on sodium. Don't forget to subscribe.